Hey there guys, this is Tom, back with the last physics video for this unit. This one is on the design of a simple microphone. So, this week's prac, we were given a spool of uncoated copper wire, coated copper wire this time, a Perspex tube, some Glad wrap, and a couple of small rare earth magnets, and told that we could create a microphone which we could pick up with an oscilloscope. So, for our group, what we decided on after a bit of brainstorming was to use our knowledge of Faraday's law, Lenz's law, and the work we'd done in the train prac from last week to design a microphone using induction. So as you already know, when you pass a current through a wire, you end up with a magnetic field using the right-hand rule. The reverse of that, I guess you'd say, would be that when you pass a magnetic field through a coiled section of wire, you generate a current. Faraday's law. And so, based on that, we decided that we were going to have to have either the magnet or our coiled wire moving on our diaphragm, that being the thing that picks up sound, to allow us to generate a current which the oscilloscope could pick up. So, when we went to consider that, we had to figure out which would be more appropriate. Magnets obviously have a large amount of inertia compared to a coil of wire, and as a result, sticking them on our diaphragm is going to make it slightly harder for sound to move it, because sound doesn't carry as much kinetic energy as you might want to move two rather large magnets. However, attaching the coil to the wire was going to present the obvious problem of, well, now where do we put the magnets? They need to be set pretty close to the coil and have the magnetic field lines passing through the center of the coil. But that was going to prove difficult to do, so instead what we decided on was to mitigate for the fact that we were going to have the magnets moving. We'd wrap our wire around the Perspex tube lots and lots and lots of times, and this would give us a greater number of turns, obviously, which would in turn give us a greater current, which would then be picked up by the oscilloscope. For refining this, however, we needed to consider what was going to make it difficult to use our microphone, and that boiled down to these guys. So, the diaphragm material. Glad wrap, although it is flexible and it does, vibrate reasonably well in response to sound, isn't very elastic, and it can unfortunately deform, which you tend to find when you get magnets attached to it. So it wasn't the best thing in the world. We could have used, for instance, a pair of rubber gloves or some other rubbery latex material, God knows, to give it a little bit more resilience against the fact that these magnets are going to potentially damage the material by squeezing against it and whatnot. But we also want that material to be taut so it responds well to sound and picks it up clearly. Magnets and wires. We also wanted high field strength for our magnet, because the higher the field strength, the more current we're going to get through our coils. Again, more loops. The more loops we have, the larger the current we get passing through them, and the less resistivity of the wire we have, the greater the amount of coil, because Ohm's law. So that all boils down to the cross-sectional area of the wire. A smaller cross-sectional area increases resistivity, but gives us more loops in the same area, and so as a result, what you'd be looking for is something that has both low resistivity and a small cross-sectional area to give you the greater current. The last thing we have to consider is the oscilloscope, and so that's fairly sensitive, and so we want to cut out as much noise as you can find as we can, which unfortunately in an environment with lots of wires in the walls you get a lot of. For the conclusion, we found that our microphone could pick up up to 350 to 400 hertz reliably. Above that, the amplitude of the sound and the amplitude of the movement just wasn't quite enough to overcome the noise. Because of that, higher frequencies in this got lost, and so we couldn't use the microphone that we designed to pick up higher frequency sound. If we were going to attempt to make a better microphone, we'd want one that obviously picked up better sound, and so we'd want significant gain and amplification of sound coming in to it into the oscilloscope to beat out the noise. And so unfortunately we couldn't do that, but we still managed to get a bit of a recording going on. So overall I reckon it was a success. Thanks guys, hope you enjoyed it.